Hey there, this is Math 6, Unit 4, Lesson number 15. Alright, we're going to first of all talking about volume of prisms with fractional measurements again. So how many cubes with an edge length of 1 inch fills this box? Alright, so it's a great little question here. If we're thinking about 1 inch cubes, we know that we can get 3 on this side and we can get 10 on this side. So thinking about just the base itself, if you wrote it as a flat two-dimensional thing, would be a 3 by 10, which is going to be 30 cubes on the bottom. But then we have to think about how tall that's going to be. So the height here happens to be 4, so we would stack up 4 stacks of these. So 30 times 4 is going to give me 120 inch boxes to fill this up. So this is what we did last time in one of our last lessons. So we can get 120 of these things inside of here, is the idea. Okay? We're not going to do that right now. That's crazy. We used the little applet last time to show how we could grow that up, but we'll leave it like this for now. Now, if the cubes had an edge length of 2 inches, would more or fewer cubes be needed? If they had a length of 2 inches. Well, if the length of 1 inch cube, right, if it's a 1 inch cube, took me, 120 to get in there. If I did a 2 inch cube, a 2 inch cube is made up of how many 1 inch cubes? Well, it's made up of 8 of these guys in there, right? There's already going to be 8 of them in there. So if I'm going to use a 2 inch cube, I don't need as many of them, do I? One, it's larger, right? I'm going to need 1/8 as many as I did before, because of just it's that much, it's 8 times larger. So I would say if I use a 2 inch cube, I'm going to need fewer cubes altogether. Okay, because 8 1 inch cubes fit inside of 1 2 inch cube. But if I went the other way and the edge lengths were a 1/2 inch, would I need more or fewer? Well, I'm making them smaller, so I'm going the opposite direction now. So I'm going to certainly need more. And that's because it takes 4 1/2 inch cubes to fit inside of one of them. Okay, so it's just gonna. I need more. I need more. All right, moving on. Diego correctly points out that 108 cubes with an edge length of 1/3 inch are needed to fill a rectangular prism 3 inch by 1 inch by 1 1/3 inch. Explain or show how this is true. So how is this true? Well, okay. Because the cubes are 1/3 of an inch, I'm going to have to multiply each of these values by 3 in order to see how many it would take. Right? Let's look at the 1 inch one. If this is 1 inch and each cube is only 1/3 of an inch, I need 3 of them in order to make a 1 inch length. So if I take the 3 here and I multiply it by 3, that's going to give me 9. If I take the 1 and multiply it by 3, that's going to give me 3. Now I take the 1 and 1/3. 3 times 1 is 3, plus 1 is 4/3. So 4/3 times 3, reduce, that gives me 4. So I'm going to need 9 cubes to make 3 inches, 3 cubes to make 1 inch, and 4 cubes to make 1 1/3. How many cubes is that all together? It's 9 times 3 times 4, which is 108 total cubes. The next question asks, what is the volume in cubic inches of the rectangular prism? Explain or show how you know. Well, all right. Well, our volume is going to be, we have 3 by 1. We have 3 inch times a 1 inch times a 4/3 of an inch, right? And we multiply that out, we end up with, these reduce, simply 4. How do we know it to be true? Well, we also know that because we had 108 cubes to work with, and it takes, if you think about 1/3, it takes 27 of them to make one block. I can multiply 108 by 1 over 27, and that also is going to give me 4. That's my volume. And number 3. Lynn and Noah are packing small cubes into a cube with an edge length of 1.5 inches. Lynn is using cubes with an edge length of 1/2 inch. Noah is using cubes with an edge length of 1/4 inch. who would need more cubes to fill in that cube? How do you know? Well, we're going to go with the one that's using the smaller cubes. Noah needs more. He needs more because, again, you're trying to take a space that's a 1.5. Let's call this a 1.5. Okay? What's my 1.5 space? That's a 1, and here's a half. Okay, so if I break this up into Lynn is doing 1/2-inch cubes, right? So Lynn would need 3. There's Lynn. And Noah, to make that same space, he's using 1/4-inch cubes. That's what Noah needs. So Lynn's going to need 3. Noah's going to need 1, 2, 3, 4, 5, 6 in order to make the same length of 1.5. 1.5. Okay. So if Lynn and Noah use their small cubes to find the volume of 1.5 inch cube, would they get the same value? And the answer there is going to be yes. They're going to get the same value, and the reason is because we're still relating it to the value of 1 inch, where we're seeing how it relates. While their numbers are going to be different they play with, in the end you get down to what is the space inside of there. The space doesn't change. The number of things you put into it can change, but the space, which is what volume is talking about, doesn't change. That remains exactly the same. Alrighty. So the fish tank in a nature center has the shape of a rectangular prism. The tank is 10 feet long, 1/4 feet wide, and 6 feet tall. So we can think of it like this. It's 10 feet long. If we go this way, it's 8 1/4 wide, and in terms of its height, it's 6 feet tall. What is the volume of that tank? All right, well, the volume is going to be the length times the width times the height. All those numbers multiply together. So we have 8 times 4 is 32, plus 1 is 33 over 4 times 6 times 10. Can I reduce anything? Sure. 2 goes into 4 2 times. 2 goes into 6 3 times. Then I can reduce 2 goes into that 1 time. 2 goes into that 5 times. So 5 times 3 is 15. 15 times 3 is 495 cubic feet is the volume of that fish tank. So let's use that number. Go to the next page, 495. It says the caretaker of the center filled 4/5 of the tank with water. 495 is the volume. What is the volume of the water in the tank in the cubic feet? Okay, so we know it's 4/5 of what it should be. So as a math problem, that's 45. That's going to be 4/5 of 495, or 4/5 times 495. That is equal to 396. And again, you can multiply that out and then divide there, and you get 396. So what was the height of the water in the tank? Explain or show your reasoning. Well, before, our height was 6 to start with, right? That was our height. So if we're going to do 4/5 of something, we just need to pick one of the measurements to decrease into 4/5. So I could do 4/5 of 6 to find out the height. That's going to be 24 over 5, and then 5 goes into 24 4 times with 4 left over. So the height would actually be 4 feet and 4/5 of a foot. One day, the tank was filled with 330 cubic feet of water. The height of the water was what fraction of the height of the tank? All right, so same idea here. This is going to say that I have how much water? 330 cubic feet. Out of how much should I have? I should have 495. That's how much it would be if it was full. So this already is going to give me what I'm looking for. This is going to tell me what the fraction of the height that it should be. So if I do some division here, I can do 330 divided by 495. And in our case here, maybe we say that 5 goes in here and 5 goes in there because they both end with zeros and 5s. So when I divide them both by 5 over 5, I end up with 66 over 99. I'm going to divide both of those by 11 and 11. 66 divided by 11 is 6, and 99 divided by 11 is 9. And then I can divide all that by 3 over 3, which gives me 2/3 is my final reduced answer. All right. Here's another one. Claire's recipe for banana bread won't fit in her favorite pan. The pan is 8.5 inches by 11 inches by 2 inches. The batter fills the pan to the very top, and when baking, the batter spills over the sides. Oh man, to avoid spills, there should be about an inch between the top of the batter and the rim of the pan. Claire's another pan that is 9 inches by 9 inches by 2.5 inches. If she uses the pan, will the batter spill over? Well, let's go back to her pan that she has. This first pan, because it fills it to the top, is going to be the volume of the batter she has, right? Because she has some kind of a pan, and when she fills it up, it fills up the entire thing. So that first pan is 8.5 by 11 by 2. That's going to tell me the volume of the batter. So this is 2 times 8 is 16 plus 1 is 17 over 2 times 11 times 2. Our 2's are going to cancel out. So we have 17 times 11 is 187 something or other, right? That's how much liquid is going to be, or batter is going to be inside there. That's the volume of that. Okay, that's how much is in there. So, yeah, so that's how much is in there. Now, if we didn't want to spill out, she'd have to have like, the height wouldn't be 2, the height would be 1, if we wanted that to work out the right way. Okay, so let's see what happens here. She used another pan that's a 9 by 9 by 2.5. Will it spill over? We know she has this much liquid already, or batter, to put in there. This is a 9 times a 9 times 5 over 2, okay, which is what we have so far, 5 over 2. And what we know is that 9 times 9 is 81, and, 5 over 2, 4, 81, yeah, 81. And, so I get my calculator out real quick. So she does 81 times 5 is 405 over 2, and we divide that by 2, and you get 202.5. Okay, so it definitely has a greater volume, but will it spill over the top? Okay, the batter fills the pan. Batter fills the pan at the very top, and when the batter spills the sides, to avoid spills, there should be about an inch between the top of the batter and the rim of the pan. So we have this much stuff. Will it spill over? Okay, that's a lot of batter. We have 187 there. The question would be then, if I need to leave an extra inch there to not spill over, then I'm really doing a 9 times 9 times 1.5, which is 3 over 2. Okay, so the volume of that pan is that. I actually did the wrong number there. I really want to do 1 over 2, because I have to subtract an inch. So I got ahead of myself. So that's the volume of the pan, but because I want to subtract 1 inch to not spill over, an inch between, I need to multiply by this. So 9 times 9 times 3 over 2 is actually, that's equal to 121.5. So let's think about this. That's the volume I need to fill up to be in order for it to work. Right there, that amount. Like this. But she's going to put 187 inside of that. So what's going to happen when she pours 187 of the batter, 187 cubic inches of the batter into a space 121? This one's too big, so is it going to spill over? Yes, it will spill. So don't do it. You'll make a mess, and then you gotta clean it up. Alrighty. Okay. So our last bit here. Find the area of a rectangle with side lengths of this and this. The area is going to be found by doing what? It's going to be a half times 2/3. So we get 2 over 6, which reduces to 1/3. What's the volume if we do a half and 2/3 times 3/4? Well, this is going to be 6 over 6 times 4 is 24. which is 1/4. What do you think will happen if we keep multiplying the fractions? So if we keep adding another one to it, each time we do it, it's getting smaller and smaller. So it's going to get smaller each time. So when we added 1/2 times 3/4, multiplied half and 2/3, and then 3/4, so we did 5/4, it's going to get smaller and smaller until it eventually gets down close to 0. Here, how about this one? Area 1/1 times 2/1 is 2, right? If we do 1/1, 2/1, 1/3, we get 2/3. Okay. So if we keep going here, what's going to happen? Well, we're going to end up actually getting this one. Let's just go right here. What do we have? We'd have 8/15. Okay. So what's happening here is it's getting smaller, but it's going to be close to 1. Okay. It's also getting smaller, but it's also going to be close to 1. Anyways, not a big deal. That's just a little extra. Summary stuff today. If a rectangular prism has edge lengths A, B, C units, the volume is the product multiply of A, B, and C. That's how you find the volume. That means if we know the volume of 2 edge lengths, we can divide to find the 3rd edge length if we need to. So we can always figure that out. So if we're short of something here, if we don't know one of those, but we know the total volume, we can turn that into a division type of problem and figure that out. That's the idea of today's lesson today. Let's pause there, work on your homework, and come back together in just a moment. All right, homework time. A pool in the shape of a rectangular prism is being filled with water. The length and width of the pool is 24 and 15 feet. The height of the water in the pool is 1 1/3 feet. What's the volume of water in cubic feet? Wow, that's a really shallow pool if it's 1 1/3 feet. But okay, so our volume is going to be 24 times 15 times 1 1/3. So let's rewrite this here. This is 25 times 15 times 3 times 1 is 3 plus 1 is 4, so 4/3. I can reduce 3, and there are 8 3's inside of there. So I have 8 times 15 times 4, which equals 480 cubic feet. Awesome. Number 2. Rectangular prism measures this by this by this. Priya says it takes more cubes with an edge length of 2/5 of an inch than cubes with 1/5 of an inch to pack the prism. Do you agree with her statement? She's saying if I had a length that's 2/5, it would take more of the bigger cubes than the smaller cubes to fill it. Do I agree? No, I don't agree. That doesn't make sense. If it's bigger, I need fewer. Okay? So let's just see how this works here. How many cubes with an edge length of 1/5 fit into the prism? All right, so to do this, we're going to multiply everything by 5. I'm going to take my 2 and 2/5 times 5, and then I'm going to do the 3 and 1/5 times 5. And then we'll do our 2 times 5. Okay? So this becomes 12/5 times 5. This becomes 16/5 times 5. And let's just say 2 times 5. The 5's reduce, 5's reduce. So we're left with 12 times 16 times 10, which equals 1,920. Explain how you can use your answer in the previous question to find the volume of the prism in cubic inches. Okay, so because we know that 1/5 of an inch fits inside of is the length there, that tells me that in terms of volume, we're talking about it takes 125 of them to fit inside of the 1 cubic inch, right? Like this. I have 1920 of these. So if I multiply it by 1 1/25, that's going to tell me how many, what the volume is in cubic inches. Okay, I'll leave it like that for now. Here's a right triangle. What is the area? All right, so what do we have? We have lots of numbers here. So what can I use? I know I have a height here. That's nice. I have a height and a base, but no area. So I can't use this. I can't use this height and that base. I can use this height and this base to find the area. So that's going to be area equals 1/2 times the base times the height. And in our case here we have 1/2 times the base of 1 times the height of 3/4, which equals 3/8. So now I know the area. Alright, that's my area is 3/8. What is the height h for the base that is 5/4? So it says, okay, well what if you do this one? What if you said that we're going to do this one like that? And we're going to use those numbers. I can do it now. Why? Because I already know that the area is 3/8. It's not going to change. It's the same triangle. And that area is going to equal 1/2 times the base that I know. And now I can find that height right there. So let's do this part here. This is 5/8. I'm multiplying it together. And then we're going to do division. We'll do 3/8 divided by 5/8 equals h. We're going to multiply by the reciprocal. And the 8's cancel out. And we're left with 3/5 is the height of that triangle right there. Alright, and our next one, number 4. To give their animals essential minerals and nutrients, farmers and ranchers often have a block of salt called salt lick available for their animals to lick. A rancher is ordering a box of cube-shaped salt licks. The edge lengths of each salt lick are 5/12 foot. Is the volume of one salt lick greater or less than 1 cubic foot? Okay. Alright, so is the volume of one salt lick greater and less than 1 cubic foot? Well, let's see here. Well, to be a cubic foot, you would need it to be a foot by foot by foot by foot to be cubic foot. This salt lick is 5/12 of that. 5/12, 5/12, 5/12, 5/12. How could that be more than 1? I don't think that's possible, right? Right? Because even if you do the math on that, 5/12 times 5/12 times 5/12, that gets you 125 over 1,728. So that is not going to be quite 1. Okay? Now the box that contains the salt lick is this dimension. Alright? How many cubes of salt lick fit in that? Explain or show your reasoning. Okay. So how many of them are going to fit inside of there is our question. Okay? So the volume of this thing, first of all, let's find the volume of this. This is going to be 1 1/4 times 1 2/3 times 5/6. So that becomes 5/4 times 5/3 times 5/6, which is 125 over 72. So the volume is going to be that for the box. The box volume is that. Now the volume of 1 cube is that. So I want to know how many of these fit inside of there. So if I know my volume is 125 over 72, I want to know how many of these are going to fit inside of that. Oops, 1728. So how many groups of this fit inside the box? So that becomes 125 over 72 multiplied by the reciprocal, 1728 over 125. Notice how those cancel out. And then 1728 divided by 72 is actually equal to 24. Tells me I got something going on right there. Number 5. How many groups of 1/3 are in 3/4 of an inch? So what are we doing? We're doing 3/4 divided by 1/3, which is 3/4 times 3 over 1, which is 9/4 or 2 1/4. There. How many inches are in 1 2/5 groups of 1 2/3 inches? So this is asking how many inches are in 1 2/5 groups of 1 2/3 inches. That's what it's asking. So it's actually a multiplication problem. So this is 5 plus 2 is 7/5 times 3 plus 2 is 5/3. Reduce, reduce, you get 7/3, which is simply equal to 2 1/3 there. All right, the last one, we have a ratio table of flour to water. Complete the table with the values. So let's complete the table here. There we go. A little review from Unit 2. All right, so to go from 1 to 4 is multiplying by 4. So we can do this times 4. That becomes 4 over 2, which simply equals 2. That's exciting. All right, to go from 1 to a half, let's go this way. This is going to be divided by, or we can just multiply by a half. So if we do a half times a half, times a half, times a half, we end up with 1/4. That's not too bad. Okay. Now to get to a 3, I don't like any of these numbers to get to a 3. Just not a fan of those, right? So here's what I'm going to do. I'm going to do a little shortcut here. I'm going to go to 1. Why? Because I like 1. So how do I go from a half to a 1? I do a half times what? 2. Times 2. So what about if I do 1 times 2? And 1 times 2 is 2. So now I have a ratio with a 1 and a 2. So now let's go back this way. How do I go from 1 to 3? Times 3. And 2 times 3 is 6. There you go. That's it for today. Have a great day, and we will see you next time.